In this video, we're going to have a look at the proofs of the properties of a parallelogram. In the first video on quadrilaterals, we said that the definition of a parallelogram is that it's a quadrilateral with two pairs of opposite sides that are parallel. After this, we then accepted that these sides are also equal in length, that the opposite angles are equal, and that the diagonals bisect each other. But as you know, in geometry, we can't just accept anything. It has to be proven. So all of these properties have already been proven using abstract mathematics. And in this video, we are going to have a look at those proofs. The first property is that both pairs of opposite sides of a parallelogram are equal. Remember that this is a property that we already accept as true and use, but now we are going to prove it. So at the moment, all we know is that the pairs of opposite sides are parallel, and we need to now prove that AD is equal to BC and DC is equal to AB. To do this, we are going to divide the parallelogram into two triangles by drawing one of the diagonals. Now we are going to prove that these two triangles are congruent, because remember that congruency means the two triangles are exactly the same. So then we can make the conclusion that the sides are the same length. If you would like to first revise congruency, you can follow the link in the description to video 2. So now we are going to prove that triangle ABD and triangle CBD are congruent. Firstly, we can say that side DB is a common side in these two triangles and therefore equal. Next, we can make use of our parallel lines, and by using alternate angles, we can say that angle ADB is equal to angle DBC. Similarly, we can also say that angle ABD is equal to angle BDC. So now we have a pair of sides and two pairs of angles, so we can say that triangle ABD is congruent to triangle CDB, and our reason will be side, angle, angle. From this congruency, we can now make the conclusion that side AD is equal to side CB and side AB equal to CD. So we can write down that AD is equal to BC and that DC is equal to AB, and our reason will be our congruent triangles. So, by simply using that the pairs of opposite sides are parallel, we could prove that these same pairs are also equal. The second property of a parallelogram is that both pairs of opposite angles are equal. And again, we are going to prove this by simply making use of the fact that the pairs of opposite sides are parallel. This time, we're not going to make use of a construction, but it does help if you make one of the angles x. So I'm going to say, let angle A have a size of x. Now, by making use of co-interior angles, we can determine the size of B. So B will be equal to 180 degrees minus angle A, and angle A we made x. The reason will be co-interior angles with our parallel lines AD and BC. And by making use of the second pair of parallel lines, we can draw another U to determine the size of D. So D will be 180 degrees minus A again, and here the reason will be co-interior angles, and this time the parallel lines are DC and AB. With a third U, we can determine the size of C in terms of x. Angle C will then be equal to 180 degrees minus angle B, which is 180 minus x. And if I now simplify, I will have 180 minus 180 plus x, which means that C is x. And here we can now clearly see that angle A is equal to angle C, and angle B and D are the same. So our final conclusion is that angle A is equal to angle C, and that angle B is equal to angle D because they're both 180 minus x. The third property is that the diagonals of a parallelogram bisect each other, and we are going to prove this by making use of the fact that the pairs of opposite sides are parallel, and we now know that they are also equal. For this proof, we are once again going to make use of congruency, but when both diagonals are drawn, there are 4 triangles that you can choose from. I'm going to choose to prove that triangle ADE and triangle CBE are congruent. We already know that side AD is equal to BC because they are the opposite sides of a parallelogram, and we can also say that angle E1 is equal to angle E3 because they are vertically opposite angles. And lastly, we can make use of alternate angles to say that angle D1 is equal to angle B2, or you could have chosen to prove that angle A1 is equal to angle C2. And once again, we have a pair of sides and 2 pairs of angles to be able to say that triangle ADE is congruent to triangle CBE. From this congruency, we can now say that side DE is equal to side BE, and on our sketch you can see that those are the 2 parts of the one diagonal. We can also say that AE is equal to CE, and these are the 2 parts of our other diagonal. So we can write down that DE is equal to BE and that AE is equal to CE, and this comes from our 2 congruent triangles. And here we've proven that the diagonals bisect each other. Even though you are allowed to accept and use these properties, we can also ask of you to prove them like we've just done. Because these are abstract proofs without any specific angle sizes or side lengths, they will always stay the same. So you are welcome to study them by heart.